Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. The next piece in line is going to be just that, the next piece up. I am going to work on part number 5, and that is the column base. Column base starts off looking like, let's see if we can get this in focus. Starts off looking like this. Now, it was nice of the manufacturer, PM Research, to leave the boss on the end of this part as an assist to hold to spin the rest of the part. But this is a good opportunity to uh, implant in your mind, if this gate isn't concentric to the part, then the features on the part are at the mercy of the gate. So the first thing you want to do, besides filing off all the flash lines and cleaning it up, is to hold on some piece of that casting and establish a concentric relationship to that gate with the rest of the casting. Then you can flip it around, trust it, and machine it as required. And that's exactly what I'm going to do. So I'm going to hit the bench with the file, clean off all the ugly, give it a little bit of a blast, look for some type of round diameter out here on the end that I can trust, and then we'll pop it in a lathe, clean this up, and start from there. Let's do it. Okay, for anybody wondering why I'm not just going to finish this right now, the tab or the riser, the gate that I'm holding on is not, you can see the movement in this part. Cannot trust it under machining load. Once you establish a diameter you can trust, which is what I just did. Flip it around. Let's see how it spins now. Right now I'm looking at the features that I cannot change, and I want those to run as true as physically possible. So that's this body right in here I want to run. This out here I can turn, this I really can't. So I'm going to try to get this to run as concentric as possible, clean this up, and then flip it. Dimensions on this part are given from the center of this boss right here to the back side, and then from the back side to the front. So by subtracting those two dimensions, I know what it is from the center to this shoulder right here. I will set my turning tool to the center of this boss, back it out for my zero surface. I can establish this. Once this is cut, that'll cut, and this will fall right in. Aligning the tip of the turning tool to the center of the boss as my zero. I can work back and forth from there. Next step in the process is to clean up this back shoulder right here. And I think you'll see once I clean it up why it was so important to get this body to run concentric. Strictly cosmetic. This particular operation needs a little bit of explaining. The part is now positioned in a 5C collet in a square collet block. I am sweeping the front and rear jaws of this setup to establish the zero center line of the part. I know the block is true, I know the part is true to the block, but now the rotation needs to be set. The little boss that you see center screen sticking straight up is the shaft receiver on this part. The part is loose in the collet. So I'm going to bring a pin down that's about the same size as that boss, and I'm going to rotate the part, physically by hand rotate the part, slipping it in the collet until it lines up by feel and by eye with that pin. Once I'm happy visually that everything is going to line up, I will torque down the lock nut on the end of the block and keep it right where it is. Now this is not a locator feature, this is just a rotational locator feature. I will ultimately use an edge finder to find the center of that for the actual drilling operation. So make the collet snug while you're doing that, but not tight. And when it comes time to snug it down, make sure it doesn't move, double check it again before you move on. Simple. The part is now reoriented to a vertical format, squared with a 1, 2, 3 block, and I'm sweeping the hole for 0, 0, the drilling operation. Rotated back down to a horizontal format. I have a pin in the counter bore and I'm using a tool bit to set the height of this cutter. This small boss on the side needs to be subsurface to the flange on the end, which is why I couldn't do it before. So I'll mill it off to the correct height on the print. Then we'll move on to an edge finder to locate the actual center of that boss, like I said I was going to do. Move over, drill it, and ream it. And for those of you with very good eyes, I double checked the dimension versus what it looked like and realized I was 39 thousandths, 1 millimeter too high. So yes, that surface is lower in this shot than it was in the last shot. Always double check your work. When in doubt, check it out. Using an appropriately sized gauge pin in the hole that I just reamed in this, I'm going to rotate it against the 1, 2, 3 block to establish the square. Tighten it down. Visually find the edge of this without using a edge finder. This is not a critical feature. This is an oil hole, but I did want it rotationally correct. It's going to start off with an end mill to make sure that the drill I'm going to use does not walk off of the apex of that casting, because it is kind of nasty. Well, for a 1/16 drill, it's nasty. And then I'll push through it with the 1/16 drill, and this part will be complete. Quick look at the piece before we move on. This is the column base casting. This is what's going to hold the column, absolutely. This is the rear shaft that will hold the pulleys, variable speed. And this is not a mismatch in the surfaces. This was taped off, and that is where the blasting stopped. So that goes up inside. The little hole in the corner here, right, is the oiler feature for the shaft, because the shaft rotates, the pulley rotates, but the pulley doesn't rotate on the shaft. The shaft rotates inside the casting. Mounting holes. There you go. Let's keep rolling. Next piece in line is the bearing block casting. This is a relatively straightforward piece. This is the receiver for the shaft that the lower pulley rides on. A couple of holes, couple of flats, and away you go. We're going to take some files, going to clean this up before we get around to actually machining on it. So a little handwork, and I'll be back. First step on this little part is to bring the top protrusion down to a very specific width. I'm going to do that. I'm going to center it up to the small base at the same time. I'm going to do that by indicating the opening in the jaw. All right, once you have a setting that you like, zero everything out. Now, depending on which cutter size you use, naturally just walk it back and forth about that center line, equidistant on both sides to bring that dimension in and true it up to the base. You can then hold on this, because you know you have parallel central surfaces, and do the bottom. Let's get it done. If you're curious as to exactly what I'm about to do, I'm using a 250 cutter, and a 312 long feature is what I'm looking for. So 312 plus 1 diameter, which is 2 times the radius, will give me the center to center movement to accomplish this. It's 281 each way. Very simple. Once the center of this gap is zeroed, shift, shift, off you go. The next operation, although very simple, is also technical in as much as you remove support material and the part could migrate during the machining. I need to put the shaft hole through the end of this casting right here. And if you were to squeeze it this way, the pressure is across where the feature is going to be created. It'll be squeezing like my fingers are holding this. As you remove the center of the round part, the wall thickness decreases and it could collapse and choke the cutter. So it's not a technical move, it's just something that you need to be aware of when doing something like this. If you remove the support material, you could choke the tool and then you have a real problem on your hands. So I'm going to probably stick this on a little fixture plate and clamp on the ends here so that there is no pressure on that hole and it stays round during the process. Drilling the receiver hole in this small casting is going to be done on a jig left over from the mini lathe series. I machined off the end of the fixture so we have a good reference surface as a 0, and knowing where this surface was as I moved over and knocked these two holes in, which match the holes in the base of this part, I knew exactly how far to move over in a vertical format to find the center of the bolt pattern or the hole pattern. That gives me the center of the boss right here. Knowing the thickness of the plate right here and the height required on the print gives me the center line here. Anytime you go from off-axis features like this, knowing where you're at is critical. This is a support block for the lower pulley and I just couldn't have it out of line, so I didn't want to trust the outside of the casting for any reason. The part is located entirely from these pins and from a flat surface. Clamped securely, this particular hole should be easy to locate and machine.